Please, number 3 is available for submission until 12 o'clock, which means the next hour. So I already have, you know, some people already submitted. Okay. So, all right. So we're going to continue our chapter 5, right? Last time we learned what was a domain, right? Last time, what was a domain from a graph, right? What was a domain from a graph? We learned that what was a range and what was a domain from a given graph. So just to check that real quick, if you go here, I will share my screen. Okay, chapter 5. Okay. All right, so let me share my screen and then you're going to see. So everybody can see my screen right here?
Yes.
All right.
Yes.
That's real quick. Can you tell me what is a domain of this function, please? From, you know, the function number 25 that you see.
Is it -3 to 2?
-3 to 2, right? I agree with you. So the only thing now is you have to write it exactly as an interval, right? I agree it's a -3 to 2. We just need to write here the domain here is, you see, if you write this, everybody, if you write this is not an interval. These are two numbers. When you write this, your answer is wrong, right? Everybody, if you write only this, your answer is wrong.
So it has to have brackets around?
It have a bracket or parentheses, exactly, to make it an interval.
Okay.
So don't lose points, do not lose easy points by writing -3 2, and then you get no credit for that. Okay, so okay, -3, what do you think? Should it be a bracket or a parentheses?
A bracket?
A bracket, right? And the reason is because at the end, what we have?
A number?
We have a closed circle, right?
Okay. Yes.
We have a dot, so that is why we put a bracket on. Now 2, what do we put around 2? A parenthesis or a bracket?
A bracket?
Look at 2 right here. Look at here. What do we have here actually? We have an open.
An open circle. I thought because it ends.
Yeah, when it ends, you know, it is the end of it, right? It does end at that. The graph ends here, but this point is not included.
Okay, not included. Okay.
Okay, so we put a parenthesis. Bracket means included. Parenthesis means not included. Okay? All right. Now for the range now, remember the range is about the y values, right? What is the lowest y value to the highest y value? What you can tell me? What is the lowest y value of the graph?
-5.
Everybody sees -5? That is the first point. The graph starts right here, and the y is -5, right? What is the highest y attained by the graph?
4.
4, exactly. So around -5, 4, around that, right? -5, should it be included?
Yes.
We put a bracket. 4, should 4 be included?
Yes.
Yes, we put a bracket again. You see, these questions right here, they can be simple questions if you know exactly what to do. They can be very, very simple questions, right?
Question.
Yes.
In what circumstance would like 4 not be included? Like, is there a circumstance in the range that
If it was this, like this, the only time somebody is not included if you put an open circle at that point.
Okay.
Right? Mhm.
So
So
like
now,
if it ended like on the y-axis.
no, even if it doesn't end, you know, we can put a hole, or we can put a hole in a curve. You see, even if it doesn't end, you see here the circle I put around 4, it doesn't mean the graph does not end there. The graph keeps going, but it's now 2 pieces now. Okay, you see this graph right here. When we talk about the ending, it's like the end point. If this here you don't see nothing further, it means the graph ends here. But you can do this. Okay, this graph has how many pieces?
2.
Has 2 pieces, and that number, that y here, will not be included, nor that x. Both of them will not be included, because this point says whatever x and whatever y here, these two values, this x will not be included in the domain, this y will not be included in the range. Okay. Every time we want to exclude somebody, we put an open circle around that. All right. So now we go to the next stuff right here. Somebody asks you, what is f of -1? You see, we want to find f of negative. Again, these questions are not calculation questions. They are not. What is f of -1? F of -1. We mean here, -1, how we view a -1, do we view it as an x value or as an y value? This -1 here, is it an x value or a y value? What do you think? It's an x value, right? Thank you. The next one here is an x value. It means on the graph, I have a point where the x is -1. I'm looking for the y, okay, from the graph. Okay, that y will be f of -1. Okay, that y right here is f of negative. How are we going to do it? Very simple. -1 is here, right? Okay, that is -1. What I do? I graph.
Wherever there's an x.
Yeah, this is my x right here, right? My x is -1 here. I draw a vertical line until I hit the graph, right? When I draw any vertical line, how many times maximum I can hit the graph? Maximum I can hit the graph how many times?
Once.
Only once. Because of what test?
Vertical line.
Exactly. Because of the vertical line test. Once I hit the graph, maximum one time, what I do, I draw a horizontal line to read the y. You see here, vertical, horizontal. What is the y here? 3. So what is f of -1? 3. Everybody see that? Everybody see that?
Yes.
Yes. You see, you go vertical and then you go horizontal. You go vertical and then you go horizontal. So after that, if I ask you to find what is f of 1, what's going to be your answer? What is f of 1? Everybody.
3.
Everybody agrees is f of 1 is 3?
Yes.
Yes.
Yes, f of 1 is 3, right here, right? You see? All right, what is f of -2?
0.
Thank you very much. F of -2 is 0 right here, right? Because here, we don't need to go vertical or horizontal because we are straight. -2 is called an x-intercept, right? So f of -2 is exactly 0. What is f of -3?
Would it be -5?
Exactly. Thank you very much. F of -3 is -5, right? Okay. What is f of 2?
Also 0.
It's supposed to be 0, right? Except what you have around that point.
Oh, it's an open.
It's an open circle. So it's supposed to be 0, but since we have an open circle, we say undefined, right?
Hmm.
You see, 2 is not in the domain, right? 2 is not in the domain. You got that? You see, these questions, again, these questions, they can be very easy in a sense. They don't have calculations, right? We don't do calculation around them. But at the same time, it's very easy to do, you know, a wrong reading, right? Okay, so now, another question here, find for what x, so let me remove everything I put here. This is very convenient, by the way. To be able to write on a PDF file is very convenient. So PDF files are very hard to edit, right? So if I say for what x, find x values such that f of x is equal to 2. You see? Find the x values such that f of x equal to 2. Now that 2 right here, that 2 that you see here by itself, do you see it as an x value or do you see it as a y value?
Why?
It is a y value, you see? Thank you. Which means I have 2 here. I have 2. I'm looking for the potential x's. What are the potential x's? You see? Now, where you gonna go find the 2? On the vertical axis or on the horizontal axis?
The vertical, the y-axis.
Exactly, on the y-axis. This is my 2. How am I going to read the axis? What kind of line I draw? What kind of line I will draw to read the axis?
What color?
What kind of line?
Oh. I'm gonna like do a horizontal line to see.
Exactly. We do a horizontal line that passes through 2. And every time we hit the graph, we're going to try to read the x. You see? Now, the horizontal line is not a problem if it hits the graph like 1,000 times. The horizontal line, we don't have a horizontal line test to know if it is a function. We have a horizontal line test to know something else, but not to know if it is a function. The horizontal line can hit the graph like 1 time, 2 times, 3 times, 4 times, 6 times, right? Okay. Here, it does hit the graph 2 times, right? At 2 locations, and then you're going to have to read the x's. What are the x's? About, you know, they are not like exact numbers, but we can figure out what they are. You see, what is the first x? About how much? About negative 1.5. What is the second one? About
1.5.
1.5, right? You see, the 2 x's are negative 1.5 and also 1.5. Okay. You see, these are the kind of readings we do on a graph. We read the domain in OOD3. We read the domain, we read the range, and then we ask you what is the f of somebody, or find the values for which f of x equals this. These are the 4 questions that we read. We can have from the graph. Only 4 questions in OOD3. If we go to the next one, quickly, what is the domain of this function? Everybody, I give you like 20 seconds for everybody to think about the domain and the range. Write it down. What is the domain? What is the range? What is f of 1? What is f of 2? And for what x, f of x is, find x such that f of x equal to, let's say, you know, let's say 8. Okay, I let you like, you know, some good couple of minutes for everybody to check these 5 questions. These are the 5 questions you can have from any graph. If you know how to do them, then you're good for this topic. Yeah, you don't see, all right, go ahead. All right, everybody. Somebody, can you give me the domain? What do you think?
Negative 2.5 with a parentheses first, negative 2.5, comma, 2.5, a parentheses.
Okay, so I agree with the negative 2.5, right?
Mhm.
Okay, but here, what do we see here to the the right end? What do we see?
An arrow.
The arrow means the graph just keeps going up. Since the graph just keeps going up, it's going to end up covering the whole x-axis.
So we get
You
to
see-
do the infinity sign?
Exactly.
Okay, yeah. And I remember that after you said it.
Yeah. Every time you have arrows, it's going to involve some type of infinity, either in the domain or either in the range.
So if the arrow was on the other side, would it be a negative infinity sign?
Exactly. Exactly. You got it, right? Thank you. And and after infinity or before infinity, we always put parentheses. We never put bracket after infinity or before infinity. All right. The range now from what to y, from what is the minimum y to the maximum y? The minimum y is what number? What y value?
-4.
-4. Thank you. What do you put around -4? Bracket or parentheses?
Parentheses.
You see, there is nothing here that tells me these two, I don't have this, I don't have this. Since I don't have that, so I put, the only time we don't put brackets if you have an open circle. Okay, so that is a bracket. Until, what is the maximum y? Do we reach any maximum here?
Wait,
the left side.
why is it included? I thought there was an open.
No, right here, you see, this is -4, right?
Yeah.
I don't see the 2 points that correspond to -4. I don't see no open circle. I don't see it here. I don't see it here.
Okay.
That is the reason why -4 should be included.
Oh, gotcha. Okay.
Yeah. And then, since this branch just keeps going up, right? There will be no maximum y, right? It's going to be -4 to infinity also.
Okay.
Now, how much is f of 1? About how much? F of 1. Can you give me the answer, please? Somebody.
-3.
-3, right? -3. You see, f of 1 is right here. Okay, we can make the case is -3. But if you look at closely, it's like -2.5, right? But if I ask you in the test, on the test, I will ask you only a value that can be read exactly, okay? Not about, okay? I will ask you a value that everybody will have the same answer. How much is f of 2?
I believe that would be an x-intercept.
Yeah, exactly, it's an x-intercept. So how much is f of 2 then?
0.
0, thank you. Okay, what are the x's such that f of x is 8? How many of them, first of all? How
Two.
many x's?
2 x's.
You got 2 x's, thank you very much. What are they?
Negative 2.5
Uh-huh,
and positive 2.5.
exactly. You see, I mean, so if this is a big negative 2, let's say negative 2.3, you know, just to make it stick, right? And then 2.3, okay? You see, but you know, on the test, I will give, you tell me negative 2.5, I take it, negative 2.3, I take it, etc., etc. All right. So
Does it matter if we accidentally put the positive number first?
no, which positive number? You mean 2.38 and negative 2.38?
Yeah.
You put this one first? No, it doesn't matter here.
Okay.
We are just listing the both of them.
Okay.
All right. Okay, so that is, you know, that is what we could do reading the domain, find the domain from the graph. Well, now we can ask about the domain, not from the graph. We can ask f of x equals 3 over x minus 5, and we ask you what is the domain. Find the domain. Okay, the domain is the set of all x's. This is a domain by definition. Domain is set of all x values such that f of x exists. You see, f of x exists. So basically, the domain is a set of all numbers. When you plug in them, you don't run into a problem. You don't run into a math problem. For instance, what type of math problem we can run into? For instance, dividing by 0. Can we divide by 0 in math? We cannot divide by 0, right? So if you substitute x with any value, you see that x you see in the function, if you substitute that x with any value, and then you will get 0 on the denominator, that is a problem, okay? So the domain is all the x values. When you plug in them, you can go from beginning to the end, you don't get no problem. For instance, if I plug in 6, what I get? What is f of 6? 3 over 6 minus 5, right? That is no problem. You see, I can keep going. 6 minus 5 is 1. It's going to be 3 over 1. It's going to be, the final answer will be 3. So 6 is in the domain. What is f of 10? 3 over 10 minus 5. It's going to be 3 over 5. No problem. What is f of negative 1? 3 over negative 1 minus 5, etc. What is f of 0? 3 over 0 minus 5. No problem. But now, what is f of 5 now? Go ahead. In your head, what is f of 5? It's going to be 3 over what?
0, which would make it the whole answer 0.
That's going to make the whole answer be a problem. F of 3 over 0 is not a number. It's not 0. It's not a number. It's undefined, right? So every time I have a denominator and you ask me what is a domain, I have to say the denominator cannot be 0, right? That is a condition. So what you do, always say the denominator, whatever it is, cannot be 0, right? That is a condition. For f of x to exist for this type of functions, the denominator cannot be 0. In this case, the denominator is very easy, so x minus 5 cannot be 0, right? You add 5, so you say x cannot be 5, right? Everybody see that? So what is the domain? The domain is all numbers except for what? Except
5.
except 5. That is the domain. All the numbers except 5. The only number I found that's going to give me a 0 on the denominator, the only number I was able to find was 5. If I have found 2 numbers, I would say all numbers except this and this. If I have found 3 numbers, I would say the same, right? That is the domain. So for answer, if you say f of x equal to x plus 3 over 4x plus 24. F of x equal 3x minus 1 over x squared minus x minus 42. What is the domain of these two numbers? I mean, of these two functions? Always your starting point is to set denominator cannot be 0. That's going to be your starting point. Denominator cannot be 0. And don't try to guess, try to solve it. Try to solve the equation, okay? Go ahead, please. All right. All right. I think we can try to go ahead and try to. For the first one, can somebody tell me what are the steps they did to find the domain? You're gonna start with what?
Well, you were saying we were trying to make it 0, right?
Yeah, we don't want it. We don't want it to be 0, right? We don't want the denominator to be 0. Whether you solve equal or not equal, you know, it is the same work. But why we prefer? Okay, let's say somebody does this. Let's say somebody say 4x plus 24 equals 0, right? Okay. And you do negative 24, right? You get 4x equal to negative 24. And then you divide by 4, you divide by 4. So you get x equal negative 6. If you do this, and then you go to the next question, how much I give you? Is this the correct answer? Is this the
I thought
correct
that's
answer?
what you wanted us to do. You wanted us to find what it can't be. Maybe I misunderstood what we were supposed to do.
Yeah, exactly. So I want you to
That
find
is
what
the right answer, then.
what it cannot be. This is the right work, but not the right answer. So to avoid that, because you know, if I go to say, okay, solve a denominator equal to 0, if I just say that, I am sure 100% some students will give me this as their final answer. I am sure of that. And that is not the final answer. That is everything but the domain. The domain is all numbers except what? Except negative 6, right? You see? So if you go there, if you go to the next line and he says domain is all numbers except negative 6, then I give you the credit. But if you stop right here, you did the right job, but your final answer is not the good answer. So what's to avoid that? To avoid that, what you do? From the beginning, you do this. You see? Now that is the right answer now. So domain is all numbers except negative 6, right? To avoid forgetting the not equal sign, to avoid forgetting that, from the beginning, we set not equal to 0, right? Everybody sees that? But whether you set equal to 0 or not equal to 0, you actually do the same steps, right? We agree on that?
So you don't have to write all
Yeah, I mean,
real
yes.
numbers except,
I mean, if you write it is a plus. If you write this is enough.
okay.
This is enough, but if you write all numbers, domain is all real numbers except negative 6 is even better, right?
Okay.
Everybody see that? So please, when you ask you what is a domain, don't give your final answer as x equal negative 6. That is the only wrong final answer. This is the wrong final answer, right? You don't say my final answer, the domain is x equal negative 6. The domain is everybody but negative 6, you see? All right, so the next one. Of course, we're going to do the same. Who going to walk us through the steps here? What you did?
I mean, I kind of just was plugging numbers in to make it 0. Is there?
Yeah, that is guessing. that is guessing. It could work, but it's not like yeah, it does. You know, it could work, especially if your guests are very, very targeted, right? If you target the right numbers, you can get all of them. But that is not like the math process. In the math process, we avoid guessing.
What is
We just try to get the solutions. And you guys know how to get the solutions. Now, you know, when you do that, when you do x squared minus x minus 42, not equal to 0. How many methods we have? Now, after 4 chapters now, we have a lot of methods. We can factor, if it is factorable. We can use a quadratic formula, right? You see? But this one, we take a quick look. Can you factor it?
Yeah.
Can you factor this one? What is the factoring?
X minus 7, X plus 6.
Exactly. You see, x plus 6 not equal to 0, which means x cannot be 7 and x cannot be negative 6. So the domain is all numbers except these two numbers. You see? All the numbers except negative 7 and negative 6. You can guess them, I agree with you, because the example is very nice, yes. But it's
then
not
you
reliable.
have to plug it in to make sure.
Yeah, when you guess, you plug in the numbers and see if you get 0. But it's not reliable as a method, because if I give you an example that is not guessable, yeah, well, you cannot guess the number, then you won't be able to answer. You see.
It only works for the 7, not the negative 6.
You just guess 7.
That was my answer.
Yeah, you see, and that is also why we don't like guessing, because when you guess, you can get good answers, but it's not guaranteed if you got all of them.
But that's what I'm saying. If you plugged in the negative 6 to that equation,
You're gonna make it 0. It's gonna make it 0. I mean, you want us to check?
Yes.
Let's check together. So negative 6 is 3 times. I mean, let's plug in negative 6 into the denominator. We don't care about the numerator so much. It's negative 6 squared minus negative 6 minus 42. Negative 6 all squared is 36.
I forgot about
plus
that.
6 minus 42, which is 0, right?
All right. You win.
You see, guessing works, but is very, very limited. And then most of the time, for instance, when you have to solve x squared equal 9, everybody will guess 3, right? Everybody will guess 3. But how many solutions actually we have? It's not only 3. We have 3, and what is the other solution? And negative 3, you see? So if you guess, you will come up with 3, of course, because everybody knows 3 squared is 9, right? But then you will forget negative 3, which is also a solution. All right, so now if we give a different type of functions, if he says this, f of x equal to x squared, x cubed minus 2x squared plus 5x minus 1. What do you think is the domain here? So basically we're asking here, the question we're asking, if we substitute x with any number, would you run into a certain problem? Would you divide by 0, or would you have some odd radical, something like, some radical which is defined? If we get this one, can you imagine that? Can you imagine plugging in, substituting x with any number that you want, substitute x with any number that you want, and then you run into a certain problem? Can you imagine that? I don't see no problem here. I don't see no dividing by x. I don't see no square root. I don't see no cube root. I don't see none of that. I don't see, all of I see here is regular exponents, right? Exponent 3, exponent 2, exponent 1. All I see is the pluses and minuses. I don't see no division. So basically, this one, I have no problem plugging in any number that I want. So the domain here is all real numbers. Okay? We can plug in any number we want here. We don't divide by nothing. We don't have to divide by no x. We don't have to take a square root of any number. We have none of that here. This is a polynomial. The domain of any polynomial is all real numbers. All real every time. The domain of any polynomial is all real numbers. All right? But now this one here now. F of x is equal to square root of x minus 3. All right? So now, look. If I do, remember what we said in chapter 3, I think, when you have a square root of a negative number, right? What comes out?
The I.
The I comes out. Thank you very much. In the context of functions, can we conceive to put I somewhere? For instance, right here, the graph right here. Can you put I somewhere on the graph? we cannot put I on the graph, right?
No.
We cannot put I on the axis. There is this only regular points. The X is a real number, the Y is a real number. There is no place here for complex numbers, which means the whole chapter 5 does not use no I's. Chapter 5 does not use no I. The functions, we cannot have I into a function, right? So
Then how do
here,
you do a negative number under a radical if you can't pull out an I?
exactly, and this is our concern here. Whatever number we substitute X with, whatever number we put here, the overall number cannot be negative, okay? Because if it is negative, then I will come out, and I is prohibited in chapter 5, okay? We don't like I in chapter 5 because there is nothing we can do with I in chapter 5. We cannot like graph it, we cannot put it in nowhere. So here, if you ask me what is the domain now, I'm not worried about something being 0, like the other case, but I'm worried about something being negative. For instance, if somebody asks you, what is f of 0? F of 0 is the square root of 0 minus 3. It's the square root of negative 3. This does not exist, right? In this context, it does not exist. What is f of 1? Which is square root of 1 minus 3, which is square root of negative 2, does not exist, right? So what is my condition for the domain? For the domain here, if you ask what is the domain, I have to say x minus 3 has to be greater than or equal to 0. That is the condition. X minus 3, whatever inside the square root, has to be greater than or equal to 0. Everybody see that? I don't worry about something being 0 anymore. I worry about something being negative, right? So x minus 3 has to be greater than or equal to 0, and we solve it. Plus 3, and we say x has to be greater than or equal to 3. That is a domain. Everybody see that? If you have a square root, the domain must be whatever inside the square root has to be greater than or equal to 0, whatever it is, right? So what is the domain of? Find domain of g of x equal to square root of 5x plus 30 or plus 40. Go ahead. All right. Whatever under the square root must be set greater than or equal to 0, right? Okay. Whatever under the square root must be set greater than or equal to 0. So we have to set 5x plus 40 must be greater than or equal to 0, right? Now, can you tell me what are the steps to solve this?
So do you subtract 40 to bring it over to the 0?
Exactly. So you get 5x greater than or equal to negative 40. And then what you do?
You divide by 5 to get the x by itself.
Exactly. You see, for inequalities, the division or the multiplication, we have to pay attention. When you divide by a negative number, then you have to switch the inequality, right? We remember that? Only when you divide by a negative number, okay? But here 5 is a positive number, so we don't change anything. So x is greater than or equal to negative 8. So that is the domain, okay? So in OAE3, the only functions that we're going to ask you about the domain of are either you have a denominator, right? In this case, you solve the denominator not equal to 0. Either you don't have nothing, like a regular polynomial. In this case, you say ordinary numbers. Or either you have a square root. In this case, you solve an inequality, right? That's the only one. All right, so that was 5.1. We defined what is a function in 5.1. We saw the vertical line test, right? We saw how to evaluate a function, how to substitute the x, right? We saw how to read the domain, how to read a graph, how to find the domain from the graph, how to find the range from the graph, how to find f of somebody from the graph, etc. And now we learn how to find the domain from a given function, not from the graph. Okay, these are the 5 stuff we saw. In the next section, 5.2, we're going to see operations on functions, some algebra of functions, how to add functions, how to subtract them, etc., etc. You see, it's not very, very hard, right? So 5.2 is operations on functions. On functions. So, for instance, f and g are 2 functions, right? So that is here, we have f plus g of x. That is a sum. F plus g of x is equal to what? Is equal to f of x plus g of x. All right. This is not a multiplication. Again, I repeat again, this is not a multiplication. It means f plus g of x, right? Not a multiplication. So the sum of 2 functions is the function sum is the sum of the 2 functions. This is what we say. So now, before we see all the formulas, let's give an example so not to make it like abstract. F of x equal to 2x plus 1. G of x equal to, right, negative 5x plus 3. Okay? I have these 2 functions. Just to make it, if somebody asks you what is f plus g of 3, for instance, f plus g of 3, what I do? Very simple. It is f of 3 plus g of 3. That's it. What I said, I'm a plug in 3 in f. I'm going to plug in 3 in g and then add the 2 numbers. If I see that, I do f of 3, I plug in f. So first we do f of 3, which is 2 times 3 plus 1, which is 7. Second, we do g of 3, which is negative 5 times 3 plus 3, which is negative 12, right? And then what's my answer then? My answer will be, answer is going to be 7 plus negative 12. That's going to be my answer. Okay? which is equal to what? Which is equal to -5. Everybody see that?
Wait,
Where's the
could
plus
you
come
say
from?
that it was 3 or something?
Huh? Say again?
I'm confused where the 3 came from.
This is just an example.
Oh, you said that?
Yeah, I want to illustrate this formula right here. I want to give an illustration of this formula. I just chose 3, right, just randomly. Okay. So where's this plus come from? This plus come from what? This plus right here, right? Okay. If you put minus, what you gonna do to both numbers then? We're gonna subtract them, right? If you put a multiplication, we're gonna multiply the 2 numbers. If you put a division, we're gonna divide the 2 numbers. All right. So that is a plus. If you do this, f minus g of x, by definition, this is what? It's gonna be f of x minus g of x, right? Okay. So right here, everybody tell me, if I ask you this question now, what is f minus g of 3? Not to repeat the same work. We already have f of 3, g of 3. What you going to do to both numbers? Now it is a minus. What you going to do to the 2 numbers, 7 and -12? What you going to do there? What you going to do to them? Because here we have minus. You're going to, this is what? F of 3 minus g of 3, right? Okay. What is f of 3? F of 3 is what? It's 7, right? Minus f of 3, g of 3, which is -12, is going to be 19. All right. Okay. And the next operation is multiplication. When you do f g of x, what is your guess? It's going to be what? It is going to be
9?
no, right here in general here, it's going to be f of x times g of x, right? Where the 9 come from? F of x times g of x, right? Okay, that is when you multiply functions, you plug in the numbers in both functions and then you just multiply them. Here, I'm not going to write it down, but if you replace here, if you put here instead of plus, we put multiplication. What you gonna do? What you gonna do to both numbers, 7 and -12? What you gonna do to them? What you gonna do to them? If I put here multiplication instead of plus, you're gonna do what?
Multiply them.
Exactly, multiply them. You're going to put 7 times -12. Okay? If you do the division, f over g of x, it is division is f of x over g of x. We're going to divide them. All right? So this is what we're going to do in 5.2. We're going to learn how to add functions, how to multiply functions, how to subtract functions, how to divide functions. Right? So we're going to learn that through examples. For instance, let's do together this one right here. We have f of x equal to 4x minus 1, and we have g of x equal to x squared minus 5x plus 1, plus 3, something like that, right? Okay, everybody, let's do that together. If I ask you in the test, what is f plus g of 2? Describe for me what you're gonna do. Somebody, describe for me what you're gonna do before we're gonna do it together. Before we do it together, describe for me what you're gonna do.
Would it be f2 plus g2?
Exactly. So what you're gonna do first? F of 2 plus g of 2. How are you going to get f of 2? By doing what? F of 2. How we get f of 2? How we calculate f of 2?
Would that be 4x minus 1?
It's 4 times 2 minus 1, right? You substitute 2 in f, right? How we get g of 2? You substitute 2 in g, right? You see, what you're going to do, you do 2 actions. You do on one hand, you're going to do f of 2 on one hand, right? So this is f of 2 plus g of 2. On one hand, you're going to do f of 2, which is 4 times 2 minus 1, which is 7, right? On the other hand, you're going to do g of 2 right here, which is 2 squared minus 5 times 2 plus 3, which is 4 minus 10, which is negative 6 plus 3, negative 3, right? So that is negative 3. What you going to do to them? You're going to add them up, right? What is your final answer? 7 plus negative 3, which is positive, positive 4. So don't overthink this stuff, please. Do not overthink it. It's as simple as it can get. When you say f plus g of somebody, you plug in that somebody in both functions. Either you're going to add, or either you're going to subtract, or either you're going to multiply, or either you're going to divide, right? So we don't try to overdo it. So that is 4. 4 is my final answer. So for the same functions right here, for the same functions, I'm going to ask you to do f minus g of, negative 1. I'm going to ask you to do f g of 0, right? For the same functions right here. And then we'll ask you to do f over g of 1. All right, go ahead, please. Every time you're going to plug in that number in both functions, either you're going to subtract, or you're going to multiply, or you're going to divide, right? All right, everybody.
What number are we plugging in?
The numbers, they are right here. For the first function, you're going to plug in what number?
But to what? You're saying the 4x minus 1?
Yeah, the same functions, yeah.
And the gx?
Yes, the same ones, exactly.
Okay.
All right. So we said the first f of x is 4x minus 1, right? So let me write here. And g of x is x squared minus 5x plus 3. Okay, for the first one, somebody, when we ask you what is f minus g of negative 1, f minus g of negative 1, right? The first, what you do, you plug in, you're gonna plug in negative 1 into, go ahead.
I can try, but I'm a little bit confused on this one. I put f equals 4 times -1 minus 1, which equals -5.
Yes, and then what you did next?
And then I put g equal -1 squared.
Please don't forget to do g of -1, right?
G of -1. Okay. Equals, I'm going to write that down because I didn't.
Yes, yes. Don't forget to do that.
-1 squared. Minus 5. Times -1. 3.
Plus 3.
Which equals 9.
1 plus 5 plus 3, which is 9. Yep. And then what you do for your final answer?
I subtracted. I put -5 minus 9.
That's it.
Which equals -14.
That is it.
So the -1 that you plug into those equations is that number that comes after f minus g.
Yeah, that is good. That will be always given to you. And I said it's not a multiplication. You don't multiply nobody by -1. You don't multiply. It's not a multiplication. It means plug in -1 in f, plug in -1 in g independently, right? And then do whatever we ask you to do in the middle. If it is minus, you minus. If it is multiplication. Yeah, plug in -1 in f, right? This is what Peggy did here. Plug in -1 in g. See what she did here. And then whatever we ask you to do in the middle, you do it here with the two numbers, right? Okay. For instance, okay, try to do the next one, fg of 0. No. fg of 0. What's it going to do first?
I'm too scared. I'm embarrassed.
No, don't be. Okay. What's you going to do first?
So you put the 0 in where the x is?
In what function? In
that first one.
In f, right? So which is f of 0? F of 0 is when you put 0 in where the x is in f. We're going to be 4 times
0
minus
1,
which is -1.
-1.
On the other hand, you're going to do what on the other hand?
So then we put 0. So it's going to be 0 squared minus 5. I mean, when you say it's not times.
No, I said in the beginning. Some people, they read the beginning as a multiplication. Right here. the
But
beginning,
now when
right?
we plug it in, that's multiple.
Yeah, now when you plug in, of course, you have to do whatever operation is here. Is 5 times 0, right? Plus what?
3.
Plus 3, which end up to be positive
3.
3. Now, what you going to do to both numbers now?
So now you do multiply them though, right?
Exactly. Now you multiply, because this is by definition, because this is f of 0 multiplied by g of 0. We did the math. F of 0 is -1. G of 0 is 3. So we're going to multiply them. It's going to be -1 times 3, which is -3.
Okay.
Okay?
All right.
You see, if I did put here over division, what you going to do? What you going to do both numbers? You're going to divide, right? That's it. If I did over, which is the next one, f over g of 1. F over g of 1. On one hand, what you do, somebody else. On one hand, what you going to do? On one hand, you're going to do f of 1, right? On one hand, we do f of 1, which is 4 times 1 minus 1, right? Which is 3. On the other hand, we do g of 1, which is 1 squared minus 5 times 1 plus 3, which is 1 minus 4 plus 3, which is -1, right? So what you're going to do then, what's going to be the answer? It's going to be division, right? F of 1 is what? 3. G of 1 is -1. It's going to be -3. All right? So this is how we add, how we subtract, how we multiply, etc., etc. So now, another question we can ask is this one. And we're going to close here. Now we say f of x, same functions, 4x minus 1, g of x is x squared minus 5x plus 3. Now we ask you this question now. What is f plus g of x? You see here, we haven't said a particular x. We didn't put a number, a particular number. We just said in general. What is f plus g of x in general? This one is even simpler in a way, in a sense. This is just f of x plus g of x, right? By definition. Since I have no number to plug in, I just report f of x. What is f of x? What is f of x?
4x minus 1.
4x minus 1. Plus what? What is g of x? X squared minus 5x
plus 3.
That's it. You see, if I have to simplify, if I have to reduce it, I go ahead and reduce it. You know, I have some like terms here. We do have like terms, so we're going to reduce it. But if I didn't have no like terms, then I would be done. Okay, everybody see that? This one is even shorter. We have less work to do. Why we have less work to do? Because we don't have a particular number to plug in, right? We don't have a particular number to evaluate at. This is a general, f plus g of x. X is a general, you know. So, and then we're gonna do we have some like terms here? We have x squared, right? 4x minus 5x is -x. -1 plus 3 is +2. See? That is f plus g of x. Everybody see that? Now, if I do, are we gonna stop right here? If I do f minus g of x, what you gonna do? Tell me what you're gonna do.
So you would say 4x minus 1
Mm-hmm.
minus x squared minus 5x
Thank you very much. Exactly. It's going to be 4x minus 1 and then minus parentheses x squared minus 5x plus 3. You see? And then the next step would be just to simplify this answer. If I put multiplication, what you going to do? You're going to multiply both parentheses. If I put division, you're going to divide both parentheses. That's it. So this one, when you reduce, this one is going to be 4x minus 1 minus x squared plus 5x minus 3, which end up to be negative x squared plus 9x minus 4, etc., etc. All right, so I hope we're going to stop right here today. I hope everybody did the quiz, because now, the quiz was due at noon. I hope all of you did the quiz. And yeah, I think we have one more class before the Thanksgiving break, right? It will be next Tuesday, where we're going to start exponential functions and logarithmic functions. So I advise everybody not to miss the class. If you have never heard about exponential functions, please don't miss the class.
I have
All right? Yes, go ahead.
On the quiz, there was like one part, and I know you went over it. It's like, because I have it written in my notes, but I didn't like put in my notes like how to do it. So I was really confused. Is it okay to ask you to go over that in our next class?
Yeah. What? So
It was the one where we had to find the X and the Y also. It's like, and I think it was the last question maybe. It's like, and I don't know why. It's like, I just could not remember how to do that. And I'm sure it's something very simple, and I probably got it wrong, but I want to know how to do it.
Yeah. Okay. So you mean after we get the vertex?
Yeah, I got the
After we get the x-intercept and the y-intercept, you plot the points. You see those points you got from that, you plot them, right? And then you just connect them with a parabola.
Yeah, I think I did that whole, because when I tried to do the point when I plotted what I got, it didn't look.
Okay. So if you do a mistake on one point,
yeah,
then your parabola will not be shaped, and that's going to be the problem. Okay, how I'm gonna connect this?
Yeah.
If any mistake occurs somewhere, then very likely you're gonna get like confused because you don't see a parabola taking shape, right?
Yeah.
Because of one mistake. So when I grade, I have to take that into an account.
Yeah.
I have to take it into account because one mistake can mess up the whole thing.
Yeah, I think I made a mistake because
somewhere probably you made a mistake in one point, and then it's gonna mess up the shape. If you don't do no mistake, the shape will be clear, right? You see the shape. All right, everybody. All right, you have a nice weekend and see you next week.
Okay, thank you.
Thank you.